Hello, everybody. It's your favorite mad scientist, Gant Laborde, coming to you, well, not live, but hey, time is relative, correct? Just really happy to be here and talk about some really fun stuff. We are going to have a fantastic talk, and it's going to cover things that beginners and advanced developers should be okay with. And I think you'll learn something. So strap in, let's have fun. I'm going to mention all kinds of cool stuff, some nerd stuff. You can see Harry Potter's already on the screen. Yep. What's up? Accio Coffee. I am a Harry Potter nerd, and I am also just a nerd all around. You'll notice that during this talk. So, hey, let's get started.
Wow.
Alrighty, let's get rocking and rolling here. So the name of this talk is JavaScript Machine Learning from Magic to Science. Ooh. So who am I and why am I giving this presentation? Well, I am Gant Laborde. I'm a Google developer expert in web and machine learning. And that means that I know a bit about both of those things, enough to become a Google developer expert, which I think makes it perfect for me to kind of sit in a spot and talking about web and JavaScript and machine learning all together. I'm also a cloud nerd media developer expert, Oracle groundbreaker, AWS community builder, and distinguished Toastmaster. So if you have some kind of club or program, I'm in. I will totally join. I just love interacting and teaching and working with people. And the truth be told, that's why I wrote a book. So this is my second published book. This one's with O'Reilly, and it's called Learning TensorFlow.js. I highly recommend you check out this book. I did a lot of fun stuff. If you enjoy the kind of style and lesson of this presentation, this book's for you. So, Gant, from magic to science, eh? We're going to be magicians, and then what's going to happen? We're just going to become Rick and Morty? No. The truth is, I like to talk about magic. As a matter of fact, the first chapter in my book is called AI is Magic. Because I think that's where we all start, with the unknown unknowns. We don't know specifically how to look at the picture and the problem. So I'm going to come through this project, and you're going to follow me through taking an idea and then making it something cool and amazing that you can actually interact with. And we're going to take something from concept, where it seems magical, all the way into an actual thing where it will be science. And this reminds me of one of my favorite quotes, which is by Arthur C. Clarke. Any sufficiently advanced technology is indistinguishable from magic. And that's the way that I'm referring to magic here. So let's go ahead and zoom out. In the long, long ago, why has AI been around for so long, but people only care about it now? Well, if you go back to 2000, and I said, hey, I would love to get a picture of a kangaroo, as I'm trying to figure out how to write an algorithm that could identify if there's a kangaroo inside this photo. Well, how do I get a picture of a kangaroo back then? You would have to have a friend who visited a zoo or lives in Australia, and they would hopefully take a bunch of photos, and then they'd sit at a scanner and put those photos into a digital format, and then mail you, if you were a really, 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 really good friend, 100 photos of a kangaroo. We're in a different world now. Data is overflowing, and we have new processing power, GPUs, and advanced algorithms have been working, and honestly, computer vision's been worked towards for decades. So now if I say, oh, I would like to detect if there's a kangaroo in this photo, I can get a bunch of pictures of a kangaroo quite easily. And then I also have all the information and technology to get there to do this cool stuff. So now we have a new set of problems. It's not if we can do this. It's like why and how. And I always love starting with why. So we have to concern ourselves with some new problems now. We have to worry about ethics. We have to worry about privacy. We have to worry about diversity. We have to worry about accessibility. There has to be speed. You can't productize something without speed these days. And then it has to be all over the place. So now you have to worry about adventurous edge devices. So now we have this new set of problems. It's not, can we do it? It's like, how do we do it well? And I think the answer to that, and the whole premise of why I'm kind of leaning into this for the talk, is that the best way that you can be doing this is with, spoiler alert, JavaScript. You might be wondering why, and I say here's 6 fantastic reasons why. It can go everywhere. You could deal with it offline. You don't have to worry about this round trip. WebAssembly is amazing, flexible, and honestly, people who make websites like to make fun and silly and interesting things, right? And so I think like this is a wonderful world to get started in, but it's not everything. It's still this cavernous problem that's sitting out there because AI is so large of a picture. It could be applied to sound, text, images. And let's just go ahead and go into images. Once we're in images, what do we have? Image recognition, segmentation, detection, and then instance segmentation. And it's not even getting started there. This is just a simple idea. We have so many different flavors just inside of here. So how can we even choose to do a demo for TensorFlow.js? And I'll be honest with you, just about every AI demo. And if you're new to this will sound like gibberish. It'll sound like I'm doing some kind of Harry Potter spell. I'm not. The MNIST dataset. People who've been in this a while. How many MNIST dataset examples can we actually look at, y'all? We're just looking. The computer sees the number 8, and you drew the number 8. Ooh. All right, I drew the number 7. The computer sees the number 7. All right, I'm done. Like, I don't want to see that anymore. I'm kind of tired of seeing the MNIST dataset. I love it. It's a great benchmark, but I think we could do something a little bit more. And so that's why I say, for starting off at Magic, let's start off with a pop culture interaction. I need recognizable and playful icons that we can use. So it's time for me to go ahead and try to figure out where I can find something to do with Harry Potter to start us off here. And I thought, I know exactly what we could do. My concept is, what if we took the 4 Hogwarts houses? Now, if you don't know anything about Harry Potter, just remember, there's 4 different houses in there. They each get an animal. Gryffindor gets a lion, Hufflepuff gets a badger, Slytherin gets a serpent, Ravenclaw gets a raven. And so you've got these 4 houses inside of Harry Potter, and then you could identify specifically which house you're in by which animal that you have. That's it. If you like Harry Potter, you already knew all this stuff. If you're new to it, well, there you go. We're identifying little animals. And I was like, okay, well, wouldn't it be cool if you drew the animal and then it told you which house you're in? It would sort you into the house depending on that. Well, now I need a data set that kind of has some of this information. The great thing that we have here is that Google has 345 readily available drawings for us to use. Awesome. So I said, okay, I'm going to grab their ready-to-go drawings, and then Gryffindor will take lions and tigers, Slytherins will take snakes and snails, Ravenclaw will take bird, owl, and parrot, and then Hufflepuff will take raccoons and squirrels. And we'll take 10,000 images of each, clean them up, and then see how this kind of goes. Maybe this is how I can build this fun, instead of drawing numbers, data set. So we'd start this off with a TSNE, which I highly recommend. You can graph this out, and then you could see how distinguishable the data is from this sort of grid here. And we have a problem, right? So if we're taking a look at the TSNE, you could see right here, we've got squirrel, raccoon, and snake all sitting on top of each other. Now, it is fine that we've got parrot and owl sitting next to each other because these are categorized inside the same house. But the problem that we're getting now is that we've got too many things kind of sitting on top of each other. So maybe this isn't the exact kind of data that we want. Let's check into this. So how do we cook up some better data? Taking a look at this, first off, you can see someone actually wrote the word lion and then drew whatever that is. I don't know what that is, but they just wrote the word lion. So there's some bad data in here that might be causing some of these problems. So let's see what we can do to dig into this and maybe fix it up a bit. First off, there's just really other things. There's 2 major problems. One, That's the drawing of a bird. Just that's a bird. And then also, this is how someone did a lion another time. They just wrote the word. So there's not even drawings. So maybe I need to clean this up. And it's not that easy to tell what is going to help the most, but we have some cleaning ideas. Number one, manually cleaning. And I don't know if you know this about the MNIST data set, but they used to punish a person to clean the MNIST data set manually. He would have like an entire screen and he'd have to pick out which one, like it was a screen of zeros, and he'd have to pick out which ones weren't zeros. Yeah, that's absolutely terrible. I tried actually building an app inside of a web page to go ahead and do that. Ooh, manual cleaning hurts. I was like, okay, let me try enlarging the photos. Maybe, 28 by 28 is not enough detail for this. It's fine for numbers, but maybe I should get bigger images. No, that didn't work either. The trick that actually worked, and what I've heard a lot of people actually say works well, is that I trained the model to go ahead and give me some kind of level of accuracy, and it performed at about 80%. And then it gave me what parts were labeled wrong and set wrong. And I was like, oh, okay. And then I was able to clean the data by training a model that comes in looking for text, train a model that comes in looking for images that with like low accuracy, and really, really kind of clean the data up a bit. And that's what worked wonderfully, is like actually training AI to clean AI. Seems to be something that people do often. So this made the ridiculous data set. And that's, yes, I did name it that. And it is out there for you on Kaggle, so you can download that. So you get 8,000 to 9,000 images of each. They're small, they're memory friendly, and they're set. So now we have our data, right? So now I need to go ahead and make a model. And in order to go ahead and make the model, I'm using the classic convolutional followed by max pool iteration. It's a very simple little model. But just to walk you through, for anybody who's new to this, we're going to talk just a little bit about the model architecture. And if you know a lot about this stuff, maybe this will help out as well anyway. So we have convolutions followed by max pool, convolution, max pool, convolution, max pool, and then I hook that up to a deep neural network, right? So let's go ahead and see this. First thing we're talking about is convolutions. Now, a lot of you already know a lot about convolutions, but it is really cool to just see them in action. Convolutions have these different filters, which help you kind of draw different aspects out of an image. Here we have a picture of a jack-o'-lantern, and you can see the background's all blurred out, but then you can see that what happens there is that through the convolutions, you can see it really sort of crisp up and then give me the edges in there. And that's a classic edge detection algorithm that's being run on that one. You do this a bunch of different ways, and you can get all the different facets of an image. So yes, I absolutely love the idea of first convolutions, but I love seeing it in action. I think that helps like kind of bring things in for people. The second thing I'm going to do is that you saw those max pooling layers. Now, max pooling layers are really simple. It's just like grabbing whichever one in that window, in a sliding window, is the most activated pixel. So you can see in this example, we'll just kind of follow this one on as specifically. Out of these numbers, the largest number is 12. And so 12 gets promoted to this new set, slides the window over. The largest number here is what? Correct, 20. The largest number here is 18. And then in the blue window, the largest is 14. So we get this new smaller set of pixels from this original set of pixels there. And this might feel like it's destroying the essence of the image. You might say like, oh, well, what are you doing there? You can't just select pixels from each part of a window, which you'll end up with will be unintelligible. And the truth of the matter is, that's not how it works at all. And so I think here's a really cool video, which will kind of demonstrate what kind of happens with this. And I think this is a fantastic explanation of max pooling. So watch this with me for a moment. So that's been cut in one direction, and it makes what looks like to a human 2 dogs. Then he cuts it along the other axis. And guess what's going to happen now? And splitting those up. And he's not even grabbing the max activations. This is just randomness. And what do we see here? 4 dogs. You would say that that's a picture of a dog, that's a picture of a dog, that's a picture of a dog, and that is a picture of a dog. What a cool demonstration of downsizing by grabbing, in this case, just whatever pixel's happening. Not even grabbing the most activated pixels are happening there. So what a cool idea of what's happening there. So let me kind of pause that, move on to the next thing. And so we see this quite often in back to the MNIST example that people like to use. You could see here that I've drawn the number 5. We have some convolutions, and those are pulled down. You could still see that these are 5s, right? And then we have some more convolutions, and those are pulled down. And it starts to get into this unintelligible stuff, which is fed into a neural network. Well, we'll just do the same exact thing. So what does the code for this model look like in JavaScript? Oops, let me see, I skipped too fast. It's very simple. To do this in JavaScript, we just simply have our layers, and we write these out. Each layer that you saw in that pattern is designed and just set as a parameters here. So it's exactly like it would be inside that drawing, and the code is just describing, almost like describing those drawings. I want to have this many filters, and then I want it to size like so. And then it goes from each one, and underneath it, you can see we have a pooling. So we want it to pool, and you could tell it by the window size. So we say, all right, I would like to go ahead and do a convolution pool, convolution pool, convolution pool. And then we feed this directly into our neural network. And this is a very simple neural network that we just have 1, 2, 3 layers, and one of them's an output layer on that. And there we go. We've created the neural network that's going to read those images. So something like this actually work? Maybe. Before I go on and we start checking that out, I want to say, if you're new to machine learning, if you're new to the idea of all this stuff, just look at how simple this code is. It's just describing that structure. If you are familiar with all this stuff, then yeah, that's what you're expecting. But for people who are coming to this for the first time, that wasn't a lot of code at all, was it? So can we do it? Yeah, let's go ahead and do it. So now we've got a bunch of images. We've got them set. And now we could feed them into a website for TensorFlow.js. And I've made that as a website called aisortinghat.com. So we'll check that out right now. Let's see what we have here. Boom, aisortinghat.com. All right. So according to this, I have my 4 different houses. Gryffindor is a lion, Hufflepuff, badger, Ravenclaw, raven, Slytherin, serpent. So I'm going to draw like this. And you can see that it's starting to think that I am, that's a snake. That's a circle snake. Aha, and there we go. Now I've got a bird. Caw! Let me give it some feet. Oh yeah, it's very sure that I am in Ravenclaw. So I've actually done that quite well. So we'll clear the sketch. And remember, don't draw a skull. Do not draw a skull. Anyhow, so let's see if I can draw a lion. We'll have a little lion's head over here. Okay. Give him that's some scary teeth. Oh yeah, this looks just like a lion to me. Rawr. Don't laugh at my drawing skills, okay? This is not my fault. Go here, and he's got to have a tail, right? And he's got to have feet. Oh, this is terrible. Hey! It actually worked, right? So yeah, we've drawn a lion now. We're set. So this is using all that data. We've trained the model just like you saw, and then we've made a website. You could go try this right now at aisortinghat.com. But we have this simple structure here and my terrible drawings so that you can see what's going on. I'll clear this sketch here. Please give this, let me do a snake real quick. Let's just do one more. We'll do a snake. I thinks I'm trying to do a bird, but I'm not done. There we go. There you go. There's snake. So this works out pretty well. I'm not even going to try to draw a badger, y'all. I don't even know if I could. I think that would be a failure completely. But yeah, we were able to create a data set, run it through that very simple code with convolutions and max pooling, and then connect it to a very simple network. And we've got it running on this cool website right there. Thank you, AI Sorting Hat. So very cool. Okay, so what I think is really great about this, and one of the key aspects is you got aisortinghat.com. Yay. And then, oh, by the way, look, I have a slide that says, let's try it. I failed. That slide should have happened before this. So, so we had this idea, like, wouldn't it be cool if we drew something from Harry Potter and then got sorted into different houses? And that's the cool thing about it. There was so much data available. The algorithms are already there by a framework in TensorFlow.js. The code was really simple. And then we just simply had to go build a website, and now it's available for everybody. One of the cool things about this is that it's not making a round trip call to a server. It doesn't have to. One of the things we get there is that it can come right back inside your browser, and it's doing all of that directly in the browser. It's running the model 100% in JavaScript. This means it's extremely portable. This means it's extremely fast. There's a lot of cool things that we can do. So as a review on that, we had over 80,000 images trained, and the algorithms and the code that you saw were in Node.js. The result is just a 400 kilobyte model sitting there on the client side and runs directly in the browser. Isn't that cool? So as we adventure further into the science of all this, let's take a little bit. Can we go beyond? Because I think one of the most important aspects that we always have to do is we have to take a concept and we have to do +1. We have to just see if it goes to the next thing. So we're going to go ahead and try some transfer learning. I think that would be a fun adventure here. So you'll say to yourself, okay, Gant, I'm not familiar with transfer learning. No problem. Okay. We're going to quickly explain transfer learning as when you go to Stack Overflow and you take somebody else's solution and you copy and paste it and then you change it just a little bit so it fits yours. That's the same idea of transfer learning. Transfer learning is taking this existing model and then bringing it on over so that way it has this existing use case, and we're going to change it just a little bit so it fits our particular use case. And we can do that with this amazing AI sorting hat. We could take this one thing, it could sort you into 4 different houses, and then just go ahead and have it do something new. So let's do that, shall we? For instance, let's say that we love the idea of Star Trek. So we're leaving the magic world. We're here in science now. So we have 3 different insignia that are well known in the Star Trek world: Starfleet Command, the Klingon Empire, and of course the Ferengi Alliance. These are just 3 that I had chosen. And then what we do now is those convolutional layers are the parts that we want to keep, the parts that's identifying different drawings and taking those different parts. So when we get down to that neural network, rather than sorting it into 4 houses, we're just going to cut that neural network off, and we're going to instead move our new neural network on top of that. And this is how we get hours and hours and hours of cool training to go ahead and turn into this instantaneous benefit for us in a brand new category. So we are going to take the really cool training that happened for the Harry Potter stuff, and then cut off the neural network portion, and then add our own neural network and train that. So the way that that looks is we are going to load 150 new images. So I have 50 of each. And then we're going to use the original convolution to get the features. This is the old convolutional. And then what that was about to put into a neural network, we are going to put into our new one. And then we're going to train based on those new features. And the way you want to do this is you want to keep the old convolutional layers from changing, and you want to have the new neural network learn. Okay, makes sense? So let's see. We have this idea. Can we do that? I think we can. So how does one find 50 new images of Star Trek stuff? Because it wasn't inside our original data set from Google Draw. Well, the cool thing is with transfer learning, we don't need that much more data. I just went ahead and drew, very poorly, mind you, 50 new images. And then I think actually I only drew 10 new images. And then what I did was I slightly distorted them, making them a little bit wider, a little bit taller. As you can see here, actually, I'll point it out. If you take a look at this, I think these two are exactly the same drawing, where this one was made a little bit higher and this one was made a little bit lower. And you squeeze them down on different parts of this. This one was obviously padded on the right side. This one was padded on the top, squeezed down. You can see the same thing happening over and over again. These are actually only 10 new images that I've just distorted. So I've even put even smaller amounts of data in. But because we trained on all this amazing other data, we're hoping that with transfer learning, we'll be able to build something cool and interesting that we didn't have all the time to go get crazy amounts of data for. Let's see how that works. So what does transferring code look like on this spectrum? Well, it's not complicated at all. What we will do first is we're going to load the original model, and then we're going to shave its original neural network off. And the way we can do that is that we can go ahead and get the names of each of the layers and then say we'd like everything up to get to this layer, and then we want you to stop. And so the last layer it has is a max pooling layer with a particular unique ID on it. And this one's called max pooling 2D, max pooling 2D3. Hey, I didn't name it. It was an automatic naming. And then we say, all right, we're going to basically grab everything up to there. And then we're going to have this new shaved model, which has the original inputs and all the way up to that layer output. And then we are going to call this the feature model, where this is the base set of features that's going to identify all the pieces that are about to be put into a new model that we'll train. Now, the cool thing that you see here is that this thing is separate. It is off to the side. It is frozen, and it is all set into one piece. And this means that any of the changes are going to be happening in the new model. We're not going to be breaking or modifying or messing up the one that's been trained on tons and tons and tons of data. So we take that shaved model, and then we align it with a brand new model, which is exactly the same shape and size as our last one. So if you remember our last one, we just had a layer with 128, and then it resolved down into however many houses we wanted. We're going to have this one resolved down into 3, because there's only going to be 3 different Star Trek insignias. So we've changed this last 2 sets here. And so you can see we have, here's the shaved layer. And then here are our 2 new pieces, which are going to get trained. And then we go ahead and we compile that, and we're going to start training there. Does that make sense to everybody? Hopefully, if it doesn't, check into transfer learning. It's pretty amazing what we're doing here. And to be honest, this is what a lot of people are doing when they're building new models. They don't always start from scratch. Those of you who know a lot about this already know that. We're not going to start from scratch all the time. Here I am trying to throw 150 images. That's a small amount. That's back to my kangaroo problem back from 2000, right? Some small amount of images. I'm going to have this small set of images, and I'm hoping that this super advanced stuff that I've already taught this network transfers over and helps me with this last few layers that we're trying to do. So you say, Gant, does it work? And you could try right alongside me, just like we did with AI FYI. So I actually have a transfer learning website created, and it's also at aisortinghat.com, just /transfer. And so we can go there, and this time I didn't miss it. I have a let's try it slide. So let's go ahead and try it this time. I'm going to go ahead and load this up, and then let's get a page going over here. So we'll bring this on over, and we'll say aisortinghat.com. And here we are there. And this is where our normal model is. But if you want to go over to transfer, or you could go to learn how this model is made, and then you could say boldly go here. There we go. This will bring us to the page. So to prove to you how fast and how simple this process is, we're going to do this in real time. Yes, I could have trained the model and then shipped that, and that would have been nice and fast. But we're going to do this together on your machine in the browser. So I'm recording my screen. I have my webcam on. All my GPU is getting used for all kinds of stuff. My CPU usage is at 70%. I'm going to do this anyway. And I've got a video in the background because I wasn't trying to kill my computer enough. So I'm going to say load the training images. So when I click that, they're loading. Create the feature model, which is the shaved model that we were talking about before. So I click that. And you can saw the stars stuttered just for a moment there. And then create the transfer model. This is add my new 2 layers to the transfer model. And that happens instantly. And now I'm going to click train the model. And so this is going to train on my machine right here in real time. Click that, see the computer stutter for a little bit, and the stars stop for a second. They come back, done. It just trained the model. So that was pretty easy, but is it going to work? I know, you want to know. I want to know, is it going to work? I sure hope it does, because this presentation is recorded. I don't want to start over, right? So we have 3 different insignias, right? Starfleet, Klingon, and Ferengi. And this was originally a Harry Potter trained data set that was on a completely different model. So let's see if I can go ahead and here and do Starfleet. I'm going to go here, this. You can see it already thinks I'm Starfleet. I don't even have to finish. There you go. Was it like, there we go. We're already Starfleet. That worked out pretty well, and my drawing skills have obviously improved. So let's try the next one. All right, we're going to try Klingon here. Oh, geez. Y'all didn't sign up for art class. Does anybody remember what this looked like? It's like this. Then you got to do like this, and this comes up here like that. This is like the worst frisbee I've ever thrown. Let's do this little. Comes right there. All right, come on. Yes! All right, good. I got it. I didn't even have to do it because I didn't want to do all this, like coloring it in to get all this pixel pattern in here. But that's the way it's supposed to be. So that's good. I went ahead. It got Klingon. You can see it identified it down here. That worked out well. I said I didn't want to do this, and then I immediately did it. This is my life. All right, so you can see it kept Klingon the entire time. And now the last one, Ferengi. Oh yeah, that's easy to draw, no problem. So you come up like this, here, and it comes like that, that. And this is like this Sit down like that. All right. Oh, that's awesome. It already, it already knew. I don't know what this is, but it already knew. That's awesome. Well, I'm going to still try to draw all of it here. See if I can mess it up by trying to, my drawing here. Like that. Oh, yeah. That's fantastic. You probably, your experience may vary. It depends. Because honestly, it guaranteed will vary. You're going to train this on your machine. There's no guarantee it's going to train with the same exact accuracies and the same exact bias that mine particularly trained on. And you got all this, what is this? And then this little circle in here. There we go. So we've got it set. This worked fantastic. That was wonderful. So yeah, and you can always go back to the AI sorting hat right here if you'd like to. And then you could toggle the background animation if you're tired of it going crazy or not. So yeah, that's it. We were able to dig back into this. So let's go ahead and back to our slides. I'm pretty sure I already say this stuff in our slides, but this was so much fun. Oh, it's fun. All right. So back to the slides. What did we do? Did we have success? We started off with Harry Potter. We started off with magic. Started off with all this cool stuff. And then here we are in the wonderful world of science. We were able to build a model. We had an idea. We got the data. We cleaned the data, got it set in there. We trained the model in Node.js and we put it on a website. It worked fantastic. Then we decided we wanted to change it ever so slightly. And we were able to change it immediately in the website to have this speedy training and small data to go ahead and create a new and effective change. This is not a toy language. TensorFlow.js can do all kinds of cool stuff. Now, I know that I'm having fun. We're playing games here. We're checking cool stuff out. But this could just as easily do crazy stuff with your documents, give you suggestions on what to purchase next. It could possibly do immediate webcam transfer to help you sell your product so they could see it in their house or see it on their face or see it on their head. There's so many cool things that can actually happen here. Not a toy, super cool. So as a review of TensorFlow.js, I did build a data set called the Ridiculous dataset. Ridiculous, as it is in the movies. And then that is available on Kaggle. You can go build your own fun stuff with that as well. You can go to the Sorting Hat website. That's aisortinghat.com. It is open source. It is also explained in my book. It is super cool. Do not draw a skull. And then you can go to aisortinghat.com/transfer in order to go ahead and immediately train directly on your machine. These things are happening on edge devices. This is doing so much cool stuff that you can check it out. So that's the adventure that we were able to have. We went all the way from this mystery of TensorFlow.js through magic into science. So I hope that you enjoyed yourselves quite a bit. And if you would like to enjoy yourselves further, I have some fun stuff. So number one, I run a newsletter called ai-fyi.com. We've got over 6,000 subscribers. We've got free stuff that comes out all the different times. It is such a treat. I enjoy putting this newsletter together. I send it out once a month, though. It is a low stress, super entertaining newsletter. You will get somewhere in the middle of the month, and I hope that you enjoy it. Check it out, ai-fyi.com. Please sign up and check it out. Fun things like talks that I'm giving and cool things that I create will be in there, as well as all kinds of cool things that I find out in the wild. So AIFYI.com. And now let's say, all right, I like that, but I want to learn the ways. Gant, teach me the secrets. Teach me how to do cool things like that. I want to come up with an idea and then I want to build it, Gant. I want to do it and I want to bring it to my company. I want to build it here and there. I've got two amazing ways for you to do that right now. Way number one, about 2 years ago, I created an online course that we sell at academy.infinite.red. And I really, really, really suggest you check that out. So if you go to academy.infinite.red, you can check out this course. It is a pricey course. It is worth it. But for those of you who are watching this, the very first 5 people who enter in this code right here, Gant rocks, no space. The first 5 of you to go to academy.infinite.red and enter that in will receive the course for free. So if that code works for you, congratulations, you are one of the first 5. For everybody else, that course is a great starter. It's probably 3 weeks worth of work, and it's a lot of fun. All of you would really enjoy this book, which has plenty of crazy stuff, including explaining in detail how that website, AI Sorting Hat, you actually build that as one of your exercises in here using the ridiculous data set. This book is super awesome. I poured my heart and soul into making this. It only took like a few months, and it was a lot of fun. And I love, 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 love this book. Please, please, if you want to support a mad scientist, grab this cool book and come check stuff out. This will get you started in your journey. This is where fun stuff happens. Please join me in making cool stuff happen. I am at Gant Laborde on Twitter. Check out the book, check out the course, check out whatever crazy thing that I'm building next. And if you have any need to do some cool stuff with mobile apps or AI, and you want to do it in JavaScript, come talk to me. I have a wonderful company called Infinite Red, and our team of professionals will build the coolest apps. We have some amazing clients. We're always overflowing, so be patient with us. We have a ton. We can't hire fast enough. So definitely come check it out. And with that, you've seen all the cool, amazing magic that we have. And now you've landed in the amazing, cool science that we have. I hope that you enjoyed this adventure. Thank you so much for having me be a speaker here at this conference. I look forward to the opportunity where I'll get to meet you in person and actually shake your hand. Until then, thank you so much.